Welcome to the Modern Software Engineering channel. Here we cover software engineering practices for building better software faster and share opinions and thoughts on our industry. If you're new to the channel, make sure you subscribe, and if you like the video today, please leave a like. Before we begin, I'd like to say thanks to our channel sponsors, Equal Experts, Transfic and Mailtrap. Be sure to check them out via the links in the description. My name is Sam Newman, and given what's been going on in the last couple of days, I thought now would be a good time to talk about how we make decisions around our use of the cloud through a very particular lens. I'm sure many of you have heard about or were directly impacted by the failure in one of AWS's cloud regions on October the 20th. As is often the case with a widespread outage like this, it has kicked off a lot of discussion, both in the technology space and further beyond. As the old saying goes, never waste a good crisis. Calling the failure of a single AWS region a crisis is a bit of a stretch, but nonetheless it does create a great opportunity for us to learn from what happened, and as a result of the outage, to also maybe decide what we want to change about our own systems. So for people watching us in the future, let me briefly outline what we know at this point. On October 20th, AWS started suffering degraded performance in their US East 1 cloud region. Degraded performance is fancy speak for something not working as well as it should, or more to the point, not working at all. Early blame seems to be thrown in the direction of Dynamo and yes, DNS, but I won't do a deep dive into what caused the initial failure at this stage, as I'd rather wait for the official public post-incident report. This doesn't mean though that we can't examine the impact of the outage and see what we can learn from it. It's worth briefly explaining what a cloud region is. Like Google and Azure, AWS's cloud services are made available in different regions. Within each region, there are multiple availability zones. You can think of each availability zone as being its own data center, and while that's an oversimplification, it's not too far off the mark. These availability zones are designed to have a high degree of isolation from one another. The idea being that a failure in one AZ shouldn't adversely impact the other availability zones. So in using services in the cloud region, where appropriate, you make sure that you deploy your system in such a way that you can tolerate a single availability zone failing. For example, you might deploy multiple copies of your services deployed across more than one AZ. Availability zones outages are rare, but more rare still are failures of entire regions. And the particular region that failed on October the 20th was arguably the worst region to have failed. US East 1 is AWS's oldest region. It was the first one they launched back in 2006. For many firms that were early adopters of AWS, they would have started in US East 1, and it seems that many of them have stayed there. Companies that were impacted by the outage include Reddit, Snapchat and Zoom. ChatGPT from OpenAI was impacted, as was both Alexa and Amazon's own shopping site. In turn, many other services that ran in other locations were still impacted as they had dependencies on third parties which were running in US East 1. So even if your company wasn't in US East 1, your systems may still have been adversely impacted. One of the main questions raised in the wake of this incident is, are we too dependent on AWS? Many people came out and said that the reliance on a single vendor was an unacceptable risk, and that this is the wake-up call that we should all heed. I think the reality, though, is far more nuanced. Really, the more vital discussion to have in the short term is, are we too reliant on a specific AWS region? If your critical functionality is hosted entirely out of a single AWS region, you're vulnerable to that region going down. If you rely on third-party services who are in themselves reliant on a single AWS region, you are at risk if that AWS region goes down. In the wake of this, many people seem to push for a multi-vendor, multi-cloud approach. So instead of your system operating out of a single cloud vendor's platform, instead you deliver said service from multiple different vendors. The idea being that if a single vendor's system goes down, you can still deliver your critical services. Fundamentally, as you increase the isolation of parts of your system, you reduce the chance that something happening in one part of the system will cause issues elsewhere. This is why availability zones in the cloud region are geographically distributed. The idea is if one availability zone was taken out by a fire or flood, other availability zones would likely survive, as they are typically tens of kilometers away. In general, increasing the isolation in your system is a valid way to stop cascading failures, or formally what is sometimes known as a progressive collapse. We're going to come back to that idea a little bit later on. With what we've learned so far, we should look at the elephant in the room, which is not why are these companies reliant on AWS, but why are these companies reliant on a single cloud region in AWS? Why aren't they running their critical services out of more than one region in such a way that they can still operate if a single region goes down? Within a single region, your cloud vendor gives you services that work across all the zones in that region. For example, I can use a load balancer to distribute work across computers in the different availability zones that make up that region. If I store data in DynamoDB, I can easily access that data from anywhere within that region easily, and more to the point, quickly. As I mentioned before, the availability zones that make up a region are geographically distributed, but only to a degree. Ultra-fast network connections link up those availability zones. So when we have to send data between those availability zones and between the computers in those different availability zones, this is, reasonably speaking, pretty fast. When we start moving data between regions, though, the large distances between the regions start to come into play. Availability zones can be 50 kilometers apart, but regions can be hundreds, if not thousands of kilometers apart. This means that you expect greatly increased latency across regions. If you want to run a single system out of two regions, synchronizing data then becomes a problem. When data is written in one region, how quickly can we get it replicated to another? The further apart the regions, the longer this takes. Oh, and also, it costs a lot more to send data between regions. Cloud vendors love charging for data ingress and egress. So we've got all of that going on, the time it takes and the money it costs. But remember all those useful cloud-based services which work across an availability zone? Those same services don't exist in the same way across regions. For example, I can't use a simple AWS Elastic Load Balancer and have it balance load across services in multiple different regions. So a multi-region approach is more complex to implement and more costly to run. One argument I've been hearing for many years, and to put this into perspective, I've been using AWS since 2008, is that the cloud vendors should make cross-region solutions easier to implement. If some of those nice cloud solutions would just simply work across regions, it would make it much easier for us to deliver multi-cloud solutions. The reality is, though, that you have to be very careful what you wish for. In civil engineering, there is a term called progressive collapse. This describes what happens when a failure in one component causes failures in other connected elements. This is the classic cascading failure. A small error causes connected components to fail, and a small problem becomes a big problem very quickly. One of the key ways to avoid the progressive collapse is to reduce the interconnectedness of a system. The connections between things can cause these failures to propagate. One of the explanations for the AWS outage was a DNS issue with DynamoDB. Now, if that DynamoDB service had been available across all the regions, then that failure in DynamoDB might actually have taken all those regions down, making what was a bad outage actually a lot worse. AWS recognizes this, and that's why they've been extremely wary about introducing cross-region features, which could end up making their systems more prone to wider spread outages. This problem also speaks to one of the key challenges in resilience engineering. When we make our systems more complex in order to improve its robustness, we can end up introducing new sources of instability. Adding in the complexity of a multi-region setup might actually introduce new sources of failure. It seems to me that to be quite a rational decision to say that the cost and complexity of hedging the risk of a whole region being offline might not be worth the hassle to you. And given the companies involved in this outage, it seems that many smart, rational, and successful companies seem to have made that choice. That actually the complexity of a multi-region setup just isn't worth it to them, and that they are okay with running the risk of being taken offline via a single, although rare, region outage. So, a multi-region setup may or may not be worth it. Let's come back to the early discussion around whether or not we should be looking at a multi-cloud approach instead. With a multi-cloud approach, if you're attempting to hedge the risk of a single region falling, you have to deal with all the same complexity as running a multi-region setup. You don't have any multi-region tools from the vendor. All the associated costs and latency issues are still there. But it's actually much worse than when dealing with a multi-region setup within the same vendor, because all of those hard-fought skills you have with that particular vendor's tool chains and the ecosystem you might be used to, that's all gone. The tools, APIs, and ecosystems between the different cloud vendors are, well, they're different. To deliver a system in a multi-cloud approach, you have to build institutional skills in both cloud solutions. You also likely cannot make use of any cloud-specific services that don't have direct equivalents elsewhere. DynamoDB on AWS looks a little bit like Cosmos DB on Azure, for example, but they aren't close enough that you can treat them as being one and the same. This means you end up having to develop for the lowest common denominator or else build your own abstraction layer over the two different vendors, which then just becomes something else that you have to manage. When comparing a multi-region approach with a single vendor versus a multi-cloud approach with different vendors, we're actually hedging for different risks. With a multi-region single vendor approach, for example, running out of 2 AWS cloud regions, you're hedging against the risk of a single region being down. With a multi-cloud approach, you're hedging against the risk of an entire vendor going down. The important thing to remember about the outage on October 20th is it was just one region that went down, not all of AWS. If the only thing you're worried about is a single region failing, then a multi-cloud approach starts looking way too complex and costly, especially when many firms apparently can't justify even the cost of a multi-region approach within AWS. If they can't justify that, they certainly aren't going to be able to justify a multi-cloud approach. There is a legitimate argument around multi-cloud, but in my opinion, that's for reasons other than dealing with the issues caused by a single region failing. Being beholden to a single vendor isn't great if that vendor jacks up its prices. And there are wider questions about how much power one company should have, although it's hard to argue that Google and Microsoft aren't just as big a problem in that regard as AWS. So if you want to justify multi-cloud based on those types of concerns, then that's absolutely fine, but be clear about the risks you are really addressing and be prepared for the work and the cost that might be involved. Now, if it is those bigger issues you're worried about, and that's what's pushing you towards looking at multi-cloud, there are more sensible approaches I would recommend. Rather than trying to get the same system running out of 2 different vendor clouds, instead consider running different systems in different vendors. This gives you flexibilities in terms of building skills and relationships with more than one vendor without necessarily giving you the headaches of trying to deal with challenges like timely cross-vendor data replication. So, in the wake of a large-scale incident like this, there is always something to learn. Whether or not we as an industry actually do anything with the lessons we learned, well, only time will tell. Perhaps we'll have to wait for another outage of US East 1 to see if any companies out there change their approach. Now, if you've enjoyed today's video, then please do click like and ideally subscribe too. That's the best way to make sure we keep putting out content like this. We'd also love to see any of your comments. We do read them all. So please, if you've got any thoughts about the video, any feedback, let us know. Thanks so much for your time.